Hello and welcome to Mutually Exclusive Events. Today we're going to look at probabilities when there are OR problems. Something or something, and we're trying to find the probability of two things, A or B. What we need to think about though is whether two events are mutually exclusive. Two events are mutually exclusive if they cannot both happen at the same time. So for example, if event A is that you are in Harmon, and event B is that you have your driver's license, those are hopefully mutually exclusive because hopefully we don't have 16-year-olds with their driver's license at Harmon. Those are mutually exclusive. There is no overlap. So if I want to find what's the probability that we select a student at Aurora Schools and he is either at Harmon or has his driver's license, then I could just find the probability of selecting a student that's at Harmon and add the probability of selecting somebody with their driver's license. And those two things together would work. The word disjoint is another word for mutually exclusive. It means that there is no overlap. These are two separate things. They cannot both happen together at the same time. Okay, we can't be both tall and short at the same time. We can't be two different things that cannot coexist. But sometimes it looks like this. Sometimes the picture looks like this, and there is an overlap. These are not mutually exclusive because there is ways that you can do both. If two events are not mutually exclusive, then we have to think about it. We cannot just simply add, like we do here, all of A, and then add all of B, and think that that's going to work to find the probability of A or B, because we have counted this middle section twice. We have counted the overlap, the probability of A and B. That is right here, and we have counted it with the red, and then we've counted it again with the blue. So, if two events are not mutually exclusive and there's an overlap, then we have to subtract the overlap. And here's the formula. It looks like this. Probability of A or B will equal all the red, all the probability of A, plus all the blue, minus the overlap that we've double counted. This is a key formula. And that is if, that's only if, they are not mutually exclusive. This is the formula here for if they are mutually exclusive. Okay, let's look at some examples. We draw one card. What's the probability that is an ace or a face card? So we have to think to ourselves, is this mutually exclusive or not? Can you be a card that is both an ace and also a face card? Well, no. So ace and face card, like Jack, Queen, King, those are disjoint, those are mutually exclusive. So to find the probability of getting an ace or a face card, we could just simply add the probability of getting an ace plus the probability of getting a face card. Find out what those things are. How many aces are there in the deck? There's 4 out of 52. And how many face cards are there? Jack, Queen, King in 4 different suits. So there's 12 out of 52. So to find the probability of getting an ace or a face card, just simply add these together. That's 16 out of 52. Okay? Now this one, though, is a little different situation. What's the probability that it's a face card or a heart? Well, could a card be both a face card and a heart? Yeah, there's an overlap there. Those are not mutually exclusive. So that picture is going to need to look like this. Here's face card, here's hearts. Okay, how many face cards are there? There are 12. There are 13 hearts. Are any of them both? Well, sure, the Jack, the Queen, the King of hearts are face cards that are hearts. So 3 of those cards are here. I should have probably put up here, there were 4 cards that were aces, and there were 12 cards that were face cards, but that's okay. 3 of these are going to be both. So that means how many other face cards are there? There were 12 altogether. 3 of them are hearts. 9 of them are diamonds, clubs, or spades. Out of the 13 hearts, 3 of them are face cards, and 10 of them are the ace through 10. So now to find the probability of A or B, probability of face card or heart, we need to find the probability of the face card plus the probability of being a heart minus the overlap the ones that are face cards and hearts. All the face cards together, there are 12. All the hearts together, there are 13. Minus the overlap, although this is a probability, so we'll say out of 52 and out of 52. Minus the overlap, there are 3 hearts that are face cards. So this is 12 plus 13, that's 25. Minus 3 makes 22 out of 52. These events are not mutually exclusive, so therefore we need to subtract them. Now you notice this 22, I would get the same number if I added this plus this plus this. It would also give me the 22. It's another way to go about doing it. Okay, last example. You may want to pause it and copy this down. We've got a business that pays, either it pays overtime wages, so we'll make this overtime, or it gets temporary help. So there's times when they're in the temporary help. Overtime wages were paid during 7 months, and temporary help was hired during 4 months. But there were 9 total months in which we had temporary help or overtime. So this plus this together is equal to 9. 7 of them were overtime, and 4 of them were temporary help. So 7 plus 4 plus the ones we had together. Well, 7 and 4. If we go like this, if I have 7 and 4, that's not going to work. That's 11, right? So I need some to be in here. That's 2 too many. So if I put 2 of them in here, that would give me 5 others and 2 others, and that would give me a total of 9. Ignore this over here. It's a better way to think about it. We know that there's help for 9 months. So 7 months they got overtime, 4 months they hired temporary help, 2 of those months they did both. Okay? Now here's the question. What's the probability that an auditor will select a month in which the company paid overtime and temporary help? That's right here. Now the picture helps us to see that, right? We could also use the formula. We know, since these are not mutually exclusive, that the probability of, let's say, let's call this A, let's call this B, just to be simple. The probability of A or B, according to our formula from the last screen, is A plus B minus the probability of A and B. That's the overlap. So if I was just trying to figure this out, and I kind of reasoned my way through it and guessed and checked a little bit, but if I was just trying to figure this out, A or B is the total of 9 months, right? So this is 9 out of the 12 months. The probability of A is the probability of getting overtime, and there were 7 months they got overtime help, and there were 4 months they got temp help, plus, and this is, or minus, sorry, this is what I don't know. So this is 9/12 equals 11/12 minus my variable. So if you think about subtracting here, that'd be negative 2/12. So therefore, multiplying by negative 1, the probability of A and B equals 2/12, which is 1/6. 2 out of 12, that's what I had. So 2 out of 12 months, which is 1 out of 6. We can use that formula to help us find it. Hopefully that helps you to understand mutually exclusive events. Have a great